So here we are back at the Kerbal Space Center, and let's load up my version of the Mercury Redstone rocket. Again, pretty simple rocket. I want to use the basic parts. Way up at the top we've got the Mark 16 parachute, followed by the Oscar B fuel tank to give the retro rocket some fuel to do their task. We've got the Mark 1 command pod, designed very much like the original Mercury space capsule, and then attached to that we have three Spider LV-1R Spider liquid fuel engines. Now, in reality, the original Mercury spacecraft had retro rockets attached to the bottom of the heat shield right in the center, and they were held on by straps, but due to the design limitations of Kerbal Space Program, we can't do that, and the closest thing I could do is put these three engines around the outside to simulate the retro rockets on the real vessel. We've got a TR-18A stacked decoupler that will separate the capsule from the booster rocket. We've got a FLT-400 fuel tank on the top, and then a FLT-800 fuel tank below that. To help stabilize through the atmosphere after launch, we have the basic fins. These are not maneuverable, and we're using the LV-T45 swivel liquid fuel engine, and that's how we keep control of the vessel after liftoff. So that's it. It's a pretty simple design. And here are our initial batch of brave Kerbonauts. We've got Jebediah Kerman, who's a pilot, Bill Kerman, engineer, Bob Kerman, scientist, Edlu, Hallner, Hudori, and Weirbart, if I say those correctly, are all in the original space program, and Jebediah Kerman has been selected to be the first Kerbonaut into space. So here we are. Let's take it out to the pad. Now, the original Mercury launch was on May 5th, 1961. Liftoff was at 9:34 a.m. And when you convert that to Kerbal time, that is 5:07 in the a.m. So we're going to have to actually speed time ahead a little bit to get to the correct time. So let's go ahead and warp. Now the countdown for this actually started 24 hours, approximately 24 hours prior to the launch. During that time, they were checking out the systems, making sure everything was working correctly. They fueled up the rocket in preparation for the launch. And they had a couple delays after Alan Shepard was brought out to the launch pad and strapped into the vehicle. He was brought out by a semi-truck with a trailer on the back. That's what he rode in on the way out, nothing super sophisticated. And I remember him stepping out of the van, taking a few steps away, looking up, shielding his eyes against the light at the rocket that was going to blast him off into space. Extremely brave thing to do. Can't tell you enough how dangerous this really was. I mean, in retrospect, yeah, we had great success in the NASA space missions with no real accidents, but up to this point, our success rate for launches was about 50-50. So he had a 50-50 chance of having this thing blow up on the pad or go off course or do something really bizarre. So he was and all of these astronauts were very brave individuals. So let's speed up time here. We're looking for about 5 o'clock. So there we are at 4:09. So we're about an hour ahead of schedule. We'll see Kerbin sunrise here. Kerbal pokes its head above the horizon. Now we're waiting for 5:07. So that's close enough. So in reality, Alan Shepard would have been in that vehicle for about 3 hours after a couple delays after he got in there. And I told you the story how he had to go to the bathroom. And there was a lot of consternation between him and some of the engineers back in space control about what's going to be done about it. And he said, look guys, if you don't let me go and get me out of here, I'm just going to pee in my suit. So they worked out a compromise. Rather than delay, take the hatch off, which had 70 bolts to remove. They turned off the electrics to his suit, allowed him to pee, turned the electrics back on, and in the very dry 100% atmosphere of 100% oxygen in the space capsule, that urine quickly evaporated and life went on. So in the meantime, we are here at the Kerbal Space Center. It's a big day in Kerbal history as we are about to launch our first Kerbonaut into space, and that will be going to the accolades of Jebediah Kerman. So here we are. Let's turn the SAS on by hitting the T key. We'll hit the Z key to bring the throttles up to full speed. And we are in the final countdown. All the engineers are back at their consoles, poring over their data, making sure everything's looking good. Now after we lift off, we're going to rotate the vehicle about 10 degrees, and that will make sure that we kind of come down in the water. We're going to be looking for a maximum altitude of 131,000 meters. The actual Freedom 7 went to an altitude of 187.5 kilometers. I'm sorry, yeah, it was 116.5 statute miles. So here we go. Let's launch our first Kerbonaut, and this will be a pretty benign mission. This is a ballistic flight path. It's not going to do anything fancy, but we're going to go out there and test our ability to control the vehicle in space. So now that we've cleared the pad, I'm going to rotate the vehicle to about 10 degrees, which you can see on the heading down here. And that'll ensure that we don't come down on the land. Now once we get up to about 100 meters per second on this speed, I'm going to start doing my gravity turn. That way we'll have enough aerodynamic load on the wings to keep the vehicle stable, and we'll start to lean it on over. We'll bring it very slowly. If you go too fast, obviously you get out of control. And it's been a while since I have played the Kerbal Space Program on the computer, and in that time it's gone to the actual release version, and they've changed quite a few things. They've made it a lot more realistic. You have to worry about your speed and overheating things as you're flying your vessels through the atmosphere. They will blow up on you. Probably the biggest thing that I've noticed was that the parachutes don't act as they used to. I would traditionally come in and at about 3,000 meters, pop the chute. It would open up at about 500 feet and every time had a perfect landing, no problems. But with the new system, it's much more sensitive, so you have to watch the speed at which you deploy your chute. And you have to look at some parameters that are actually set in the vehicle assembly building that have to be changed if you want to have successful deployment of your suit or chute. So here we are leaning over to about 50 degrees, 40 degrees. Once we get here, we're going to let the vehicle accelerate. And shortly you're going to see the effects of the heat on the vehicle, at which point we'll throttle the rockets down. Now the initial booster in the Redstone rocket was lit for about 2 minutes and 22 seconds. At which time it ran out of fuel, it cut off. It waited about, I think, 10 seconds. And then there was a posigrade motor that pushed the capsule away from the booster. At the same time, the jettison tower was released from the capsule. And then an automatic sequencing program in the computers started to turn the vessel around, so it was going heat shield first through the air, through the atmosphere. So we're going to start throttling down here. Lean it over just a little bit more. At the top left, up in this area here, you can see the numbers. It's telling me my apoapsis And we're looking for 113 basically. Now that I'm starting to get some heat build up and we're about 900 knots, I'm going to continue to throttle the engines down so that we don't burn up as we go through. And I am going to slowly start leaning the vehicle over to follow the flight path marker, which is the yellow airplane marker down here. I'm trying to put the V right in the center of that, and the vehicle will continue to lean over. And we're going to throttle down to about 50%. Now up here I'm looking at these numbers to make sure that we hit our altitude of about 113. Once we're above 70 at this number right here, we will be in space. Our actual altitude right now is 26, 27. So we are going to be ending up in space no matter what we do now. You can see our fuel winding down over here. We're at 80,000 feet. We're at 50% throttle, and when we get to 113, we're going to kill the throttle. In reality, the booster would have run out of fuel, but that doesn't work this way in Kerbin, so when we get to 113, I'm just going to kill the throttle. There we go. Throttle's off. We're still in the atmosphere. We're only at 38,000 feet, but our momentum is going to carry us up to 113,000, which is definitely out into space. And after about 10 seconds, that posigrade motor is going to separate the space vehicle from the capsule. It's going to drift back and fall back into the ocean. And we're going to continue out. You can see the Kerbal Space Center way off there in the distance. Once we get above 70, I'm going to flip the vehicle around so it's going heat shield first, just like it did in reality. And in this game, as you probably know, once you get into space, which is at 70,000 feet, you see the stars and you hear the music. So right now you can see Jebediah Kerman's down there having a blast. Let's take a look at our trajectory. You can see we are planning our splashdown right over here in the middle of the ocean. This is our apoapsis at 113,000 meters. So let's go back to take a look at our vehicle as we now enter space. There's all the stars. There's the music. We're going to rotate the craft around so it's more or less upright, and then we're going to do exactly what they did in the Mercury space program, and that's flip it around so that it's at a minus 34 degree angle to the horizon. And they did that so they could make observations. So that's the orientation basically that the capsule was as it was going off through space. Alan Shepard on board, but our vehicle obviously is being piloted by Jebediah Kerman. There in the distance, just above the horizon, you can see Moon, the largest moon of the Kerbin space or the Kerbin planetary system. And you can see our booster floating behind us now about 290 meters away. Well, let's go inside the capsule and see what Jebediah is looking at. So here's his instrument panel. He's got a view of the nav ball in front of us that tells him his orientation. Over the right you can see the clock winding up. That's his altimeter. Top right you see the vertical speed. We're going up at so many meters per second. But let's take a look out the window. Now, Alan Shepard wasn't treated to a view like this. He had two small portals on the side, either side of Freedom 7, his Mercury space capsule. Let's take manual control of our vehicle here and see if we can see the booster falling away behind us out the window. Alan Shepard had two very small round portal windows on either side of his spaceship. They were about 10 inches in diameter and gave him a limited view of the world. But let's zoom in there and you can see the Kerbal Space Center. You can see the booster tumbling away. Some of the things that Alan Shepard was asked to do was to try to make observations of some objects on the surface of the planet, which he said he could do. He could make out large land masses. There was some cloud cover, obviously, and one of the delays in the initial launch was because of cloud cover. They wanted to see what you can see from space. One of the questions was, are your eyeballs going to work properly in the vacuum of space with zero gravity? Well, they did. The other question was, is your brain going to be scrambled a little bit in the zero G atmosphere? Are you going to be able to have a sense of orientation? And they did. So then Alan Shepard would take over manual control of the vehicle. Let's look down here at his nav ball. And we're going to put us back at that 34-degree nose down attitude. He was testing out the systems that would allow him to change the roll, the pitch, and the yaw of the vehicle. Everything was working fine. So it was a pretty low-key flight. Now, Alan Shepard spent about 5 minutes weightless out into space. That's it. You know, his flight lasted about 15.5 minutes from the time he took off to the time that he splashed down. But in that 15.5 minutes, he earned his place in history as the first American in space. He went on to pilot Gemini and Apollo. He's one of the fortunate few to actually walk on the moon. His footprints are up there and will be there for eternity until some meteors or something wipe out the footprints that were left behind by the original and only 12 men to ever step foot on a foreign planet. But he took the first step of an American out into space, which is being done by Jebediah Kerman at this time. Now, the original Mercury aircraft didn't have these rockets around the outside. The retro rockets were right in the center there. And about 20 seconds prior to hitting the peak altitude, which is the apoapsis here, or the apogee, as they call it in NASA, around the Earth, they fired those retro rockets, and that was not necessary to do because this is a ballistic course. No matter what we do, it's like shooting a bullet up in the air. It goes up, gravity and friction slows it down, and it eventually falls back down to the ground. Same thing that this is just a very large bullet. We launched it out into the air. It went out into space, but gravity's still pulling it down, and no matter what they did, it's going to come down. So there really wasn't a need to launch the retro rockets. It was going to come down regardless. I think it was probably primarily a systems check just to make sure everything was working properly, because if you were established in orbit, like they were from Mercury 3 on, you had to fire those retro rockets to slow you down enough, which changed your orbit around the Earth to actually come back in the atmosphere and land. So here we are about 20 seconds prior to our apoapsis. We are now going to put our throttles up to 100%, fire our retro rockets. Let's see what that does. How close is the booster that's behind us now going to come to our vehicle? You can see it's about 730 meters away, but we're getting closer to it. As we slow down, it's going to come whipping past us. You can see the fuel counting down over here on the left. Not really changing our apoapsis height very much by slowing us down, but it does make a difference. And you can see now the booster passing below us is about 300 or so meters away as it goes zipping by. Of course, that would be an absolute catastrophe if that thing hit the vehicle as it came through. 230 meters. So that's about as close as it went as it goes zipping on past. Let's take a look at the map view and see what it's done to our landing site. You can see it's gone from way out here in the middle of the ocean over more closer to this landmass here. You can see we've passed our apoapsis. We are on our way down. Our retro rockets have run out of fuel, and we are now just ballistically falling back to the Earth. So let's orient our space capsule in line with our flight path marker. So that is the orientation that we are flying. We are flying along that path right there. And as the vehicle falls back into the atmosphere, that's going to curve steeper and steeper. So our landing site should be right out in this area here. And that's why I rotated the vehicle 10 degrees after liftoff. We didn't want to go straight, otherwise we could have potentially landed on the ground over here. Now in the Kerbin system, that's really not a big deal. In fact, they are probably safer landing on the ground than they are in the water, just because of the dynamics of the game. But because the Mercury aircraft and all of the American space flights up through the space shuttle landed in the water, I wanted to do the same thing. So I rotated the vehicle about 10 degrees, aiming for this gap between these land masses, and that will ensure that we come down in the water. So Alan Shepard, and in this case Jebediah Kerman, are up there enjoying their flight. Let's go back one more time to enjoy the view from the capsule. As Jebediah is looking around, he's looking down at his feet and his hands there on the stick and over here on the throttle. He's got his orange flight suit on, pretty tight fit. Remember, the vehicle was about the size of a Volkswagen Beetle, so pretty small. Their bodies were strapped in rather tightly into a form-fitting seat, so they didn't have a whole lot of mobility, but they had the instrument panel in front of them, and same thing with Jebediah. It's a pretty tight fit. His hatch is on the bottom side. Now, whether they were hatch up or hatch down, I don't know in the real one. I didn't do the research on that. Probably, I would think hatch up, but I'm not sure. You can see the booster vehicle is now 12 kilometers away as we are now passing through 87,000 meters. Coming down, we're going to continue to align the vehicle up with its flight path so that heat shield is going to hit first. Jebediah Kerman is experiencing weightlessness, and he has completed all the tasks asked of him by the Kerbal engineers, who are poring over their data at their consoles back at the Kerbal Space Center. And you can enjoy you can see that Jebediah Kerman is absolutely enjoying the ride. His space flight, however, is just about over. When we get back to 70,000 feet, you'll hear the music stop and we will start to re-enter the atmosphere. So there we are, we're back in the atmosphere. Jebediah Kerman is now no longer flying through space. He is back to being just a regular pilot, but in free fall as this thing falls through the air. And I'm going to take the stability program off, and it's going to aerodynamically align itself as it continues to fall. It may wobble back and forth. Now when we get to about 50,000 feet, we're going to experience the effects of re-entry of the heat shield. So we'll be able to see the pyrotechniques basically as we start to slow down. That's caused by the friction. Now the Mercury capsule had a heat shield on the back. It was an ablative material that was designed to burn off and dissipate the heat rather than transfer the heat to the inside. That material would just kind of flake off, and that would be seen burning, which we see now as we enter the denser part of the atmosphere. That's also helping to slow us down. Now again, the Kerbal Space Program game has changed the dynamics on the parachute, where you have to change the parameters in order to get a successful chute opening and slow you down to a safe enough speed for landing. And that's a change. It caught me out the first time I came back to play the game. But I think we've got it right now, and you can see our surface velocity now is 1,300 meters per second. That will continue to slow down as we increase the friction in the denser part of the atmosphere. We're coming down now through 13,000 meters. You can imagine that the Kerbal Navy's out there waiting for our splashdown, waiting to pick us up. The helicopters from the recovery vessel that picked up Alan Shepard from the USS Champlain, they were actually en route before he even came down. And from the time he splashed down to the time he stepped aboard the USS Champlain was only about 11 minutes, so it's pretty awesome. Now in the Kerbal system, you can see the new system also shows you that the parachute is red over here on the left side. That tells us that if we deployed the chute now, it would fail. So we have to wait for that to turn green, and that happens when our velocity falls to about 270 meters per second. At that point, it's safe to deploy the chute. So we're about 300 meters per second now, and about 30 more meters per second we can hit our spacebar to deploy the drogue chute. You'll see the parachute over here turn green. And there it is. It's green at about 273. Drogue chute's deployed. That will continue to slow us down. And at about 1,000 meters, it will expand. And we will slow down to a safe speed of about 6 to 5.5, 6 meters per second. And that will allow us to make an extremely safe landing. So our chute is deployed. Speed is now 5.5 meters, and we are 500 meters above the surface of the ocean. Helicopters would be standing by, waiting for splashdown. And the way it worked was the helicopters would come down, they'd throw a frogman into the water, he'd swim over to the space capsule. The helicopter that would then lower a lanyard that was attached to the top of the spacecraft right here. The spacecraft would be hoisted partially out of the water, and that would allow the astronaut, in this case Alan Shepard, to open up the hatch. A second hoist was lowered down with a collar on it. He would fasten himself in the hoist, and he would be lifted separately into the helicopter, and they took all of them back in one shot. Helicopter would take both the astronaut as well as the space vehicle and set it down on top of the deck of the carrier. And again, that process from splashdown to landing on the deck of the carrier was 11 minutes, so pretty quick turnaround. The second launch, as we talked about before, was not so fortunate. All the trials and tribulations of Gus Grissom. The automatic hatch had explosive bolts on it. It was a new system, had different window placed on it. The hatch blew while he was sitting in the aircraft waiting for recovery. The Mercury capsule he was in, Liberty Bell 7, started filling up with water. He made a hasty egress out into the ocean, was treading water when the helicopters came in and swooped in. They did manage to hook on to the Liberty Bell 7, but unfortunately because of the excess weight when it filled up with water, they were unable to pull it out of the water. In fact, it was starting to do some damage to the helicopter motors. They actually had to eventually cut that cable. Liberty Bell sank to the bottom, and in that process, Gus Grissom, because he had to deflate the collar around his neck while he was waiting for recovery, and his spacesuit started to fill up with water, he almost drowned waiting for recovery. But he was eventually picked up, brought back in. But a lot of controversy over the circumstances that led to the loss of the Liberty Bell 7. But as we mentioned before, July 20th, 1999, some, 38 years after it went to the bottom, Liberty Bell 7 was discovered and eventually raised, and both the Liberty Bell 7 as well as Freedom 7 are on permanent display. The Freedom 7, the vehicle that Alan Shepard piloted, is now on permanent display at the U.S. Naval Academy. So if you ever are in the area, I think that would be an awesome thing to go see. Piece of American and space history. So this is our first manned launch. Jebediah Kerman is the first Kerbonaut in my version of this program into space. Everything went very successfully. We hit our altitudes. We maneuvered our vessel. Everything came down as precisely as we planned. We had a successful chute deployment. He is now being gently brought back down to the surface of the Kerbal Ocean. You know, I recently got a brand new computer, which is a much faster processor than my laptop that I was formerly playing this game on, but you can see up here that these numbers are yellow, and kind of frustrating that it's going so slow. Our flight so far has been 9 minutes and 7 seconds, but because the processor is so slow for some reason, I'm not sure why, it's probably taken a lot longer than 9 minutes to do this mission. It's amazed me how much variation there is from computer to computer on how this game plays. Some of them play very easily, very nicely. The trajectory and speeds of the vehicle seems to change from computer to computer. But anyways, we're now about 150 meters above the surface of the ocean. Jebediah is kind of chilling out, waiting for that splashdown. Now the actual vehicle on the bottom, between the heat shield and the bottom of the spacecraft, had a little bag, and that bag deployed prior to impact with the ocean, and that helped cushion the blow as well. And Alan Shepard, who was a Navy pilot, likened the impact with the ocean as the same as landing an airplane on an aircraft carrier, which is still a pretty good thud, but very tolerable. So we're down to our last 80 meters before splashdown. Now I'm not going to be recreating every Mercury mission. I'm going to do the highlights of a couple to give you a feel for what it's like here in the Kerbal Space Program's version. So we're going to skip Gus Grissom's mission, the second Mercury flight, the second manned U.S. space flight. We're going to go right to the third for our next video, and that will be John Glenn's first orbital mission performed by the United States. So here we are with splashdown at 9 minutes and 43 seconds. You can see this is kind of slow motion because my computer is lagging so much, and I really don't know why. It's also sitting a lot lower in the water than it normally is. And even though we don't have any fuel on board, I'm not sure what the purpose of that is either. So anyways, let's hit F3. We'll call up the mission achievements. Separation of the first stage occurred at 1 minute and 38 seconds. Our highest altitude was 113,515 meters. Highest speed was 1,505 meters per second. The ground distance covered was 633 meters, 633,036 meters, and the total distance traveled was 741,923 meters. That data is seen right here. And why is that different? Because the point where we took off to where we landed is a straight line, whereas the distance we flew was an arc, so it's a little bit longer. But we have successfully landed. Jebediah Kerman survived the flight and has etched his place in Kerbal history forever and ever. So we're going to come up here and we're going to recover the vehicle. So they have latched onto it, brought it back to the Kerbal aircraft carrier. And Jebediah is now back on terra firma, and he has an appointment with the president of Kerbal Land, and he is now a space hero. So I hope you enjoyed that. That was my version of the first Mercury space flight. If you like it, give it a thumbs up. If you'd like to subscribe to my channel, I hope to be producing a lot more videos now that I'm back in the game. And give me your comments. I always want to try to make better videos, so give me constructive criticism, things that I do bad, things that you think I can improve on. But as always, please play nicely, and we'll see you again soon with the next video. The next Kerbal mission will be the first orbit around Kerbin, and we'll show you the mechanics of doing that to simulate the mission of John Glenn. So in the meantime, you guys be safe, appreciate your family, and I'll see you soon.